Okay, as we continue with our methods of factoring quadratic equations, the quadratic formula and the discriminant. The quadratic formula will factor any quadratic equation out there. Uh, it is not the shortest method, but it is tried and true and it will work on them all. We've learned other special factoring methods for special circumstances up until now, but mostly dealing with whole numbers or integers, and in this case, the quadratic formula will factor any quadratic equation that you need. So thinking about as we use it, this is again a review of the quadratic formula, is x equals. X equals is going to be negative b plus or minus the square root of b squared minus 4ac. All of that is over 2a. Obviously, we get those a, b, and c values from the quadratic formula. A, b, c, what we see in that standard form. And I will tell you that some of the most common mistakes that I see is one, not writing the formula out. And in doing so, they forget that this is a negative number. They forget that this is plus and minus, so there's going to be two possible answers. They forget this subtraction sign is here, and then they forget that this fraction, everything is over 2a. So those are the very common mistakes that I see when using this. But otherwise, if you fill in the information and you follow the steps and you do it incrementally, it will definitely factor a quadratic equation. So using that quadratic formula and then determining the number of root types, and that number of roots is actually identified right here in just this portion of our formula. And we'll go into more of that here. But example 1, C is positive. So they're saying, hey, this value is going to be positive. At the World Championship Pumpkin Chunking Contest, pumpkins are launched hundreds of yards. The path of the pumpkin can be modeled by this function, where h is the height, and then you have negative 16t squared, usually dealing with gravity. And t is the number of seconds after launch. So we can calculate the height based on t, the time after launch. So looking here, if we factor, they went ahead and filled in my values. A is negative 16, B is 124.4, and C is 42. So they've taken the formula and they have plugged that in. There's b plus negative b plus or minus the square root b squared minus 4 times negative 16 times 42. So multiplying all that out, we end up with a positive number under the radical here. So they have, again, these two things become a positive, so that's what happened to my negative sign. 124.4 plus this over 32, and then 124.4 minus this over 32. So they're saying that looking at that, the approximate solutions came to 1.8 seconds and negative 3.2 seconds. Well, negative 3.2 seconds does not help us. Okay, we can't go back in time. So that's where we're at with that. So on the graph, we're looking at, that's 8. We have the highest point, and then the highest point is trying to think how to x equals, we can find the approximate solution. So here is 8.1. This is approximately negative 0.32, and that's going back in time because this is 0. So we're going back in time. So that's why it's like, this is not a solution. This is my only possible solution. Knowing that that's when my pumpkin lands. So here we go. Interpret my solutions. It landed here and here, but we can't go back in time. Interpret the roots. The negative root does not exist. So the pumpkin lands, hits the ground after 8.1 seconds. There you go. This diver jumps from a diving platform that is 10 feet off, 10 feet high, which makes sense because my y-intercept is plus 10. Her arc can be modeled by y equals, and in this case, I have A, B, C, okay? Where y is the height in meters and x is over time. So solve, first of all, we're going to solve. There's A, B, and C, and then we're going to interpret those roots. So I'll give you a minute, stop the video, work out this on your own. Your quadratic formula is directly above, and x is going to be equal to negative b plus or minus the square root of b, I don't like that, b squared minus 4 times a times c, and all of that is over 2 times a. So as you work that out, I've gone ahead and filled in my quadratic formula, and in doing so, I have negative 2.5 plus or minus the square root of 2.5 squared minus 4 times negative 4.9 times 10, all of that over 2 times negative 4.9. When you work it all out, you end up getting this, negative 2.5 plus or minus the square root of 202.25, all of that over negative 9.8. So you have either a plus or a minus. So I went ahead and found the square root. The approximate square root is 14.22. So I have negative times a negative becomes positive. 2.5 plus 14.22 all over 9.8, or 2.5 minus 14.22 all over 9.8. Now this one equates to a negative. We can't go back in time. So it would be the forward time movement that we were looking for. So approximately after 1.7 seconds. So my two answers, of course, were approximately 1.7 or negative 1.2, approximately. So knowing that we can't go back in time, that's why we omit that possible solution. Now here, when the negative, here's where you have to be careful that using the quadratic formula, this is going to be a negative, so this is going to be a negative, so we have a negative times a negative, which is going to give me positive. So just be aware of that's one of the things you have to worry about. So as they plug in the b plus or minus, square root of b squared minus 4 times a times c all over 2a, they've simplified this. Now some students, you're going to have difficulty going from here to here. A lot of students do not know how to simplify a radical. We cover that in algebra intensely, and we'll go on and we'll review it in class too, but if you get to this point, the calculator will take care of it for you. So you can actually put that into the calculator as negative 4 plus the square root of 84, all of that over 2, or negative 4 minus the square root of 84, all of that over 2. And that's going to give you the answer, which is going to be this, negative 2 plus the square root of 21, or negative 2 minus the square root of 21. Both of those are going to be the same. They process through it a little bit more. It's not intended to be difficult. This is actually intended to be an easy process if you remember how to simplify a radical. Obviously, we'll cover it in class, just so you know, just to make sure. Okay, so in this check, they're asking you to use the quadratic formula to solve this. You may be able to do it differently, but they're asking you to specifically use the quadratic formula. So take a chance, give it a go, and check your answer. And we'll stop with the simplified radical, but if you plug in, you have negative b, so plus or minus the square root of b squared minus 4ac all over 2a. When you fill that in, of course, be careful of your parentheses right here because that's a negative times a negative, so you're going to get a positive. Be careful of your parentheses right here because you have negative 5 squared, which is actually 25. Many people will put the calculator incorrectly and you get negative 25 and they still go with it, okay? Be careful here again that you have a negative times a negative, so that is going to be a positive number. And then simplifying, which 5 plus or minus the square root of 37 over 6. You can go ahead and stop there. If you continue on, sometimes we do need to have both answers. So just making sure we do know how to split that up and come up with those answers. So let's see here, complex roots. I will say that complex roots is going to get down to this point that when you are solving an equation, you should be able to process through this and say, hey, here's my answer. If we get complex roots, though, we will stop at this point. This is a square root of a negative number, which we are not practicing in this class. That is a skill not required. But so understand, when we get to that point, we just know that there are no real roots. No real roots just simply means that when you have a number line, y, x, I have this quadratic. That is a root, that is a root. Those are my solutions. When you have a complex solution, though, because you can't find the square root of a negative number, what that means is you may have something down here, the quadratic, that does not cross over the x-axis. So it has roots, or it has solutions, just not real solutions. Or you have something up here that does that. It does not cross over the x-axis, so you have a complex or imaginary root. So with that, just understand that we're not focused on that in this class. You just need to get to this point and say no real solutions. That's what we're focused on. Now here, the discriminant. The discriminant is the portion of the quadratic formula, you may recognize that is under the square root symbol. And that tells you how many solutions you have and what type of solutions. So you think about, if I have the square root of 4, that could be either a positive 2 or a negative 2, because a negative 2 times a negative 2 is also 4. Positive 2 times a positive 2 is also 4. So you have when you find the square root of a positive number, there are two real roots. Two real roots. And then which would be either rational or irrational. When you find the square root of 0, the square root of 0 is just 0. And what that means is you have one solution, because you don't have a positive and a negative 0, you just have 0. So if you have the square root, if your discriminant comes to 0, you have 1. And then if your discriminant comes to a negative number, you actually have complex roots. You have complex roots because it does not cross over the x-axis. And that's what they mean here by less than 0. It's going to be a negative number. But you can't find the square root of a negative number, so that's why, it's not real. Not real, it's going to be complex. So being able to understand that, and then just seeing here that, again, if it's greater than 0 or positive, that means we have two real rational roots. If it is greater than 0, but not a perfect square, so what we're finding out is that, your answer could be x equals square root of 2. That's an irrational number. You can't calculate that in your head. You require a calculator. It goes on. It's not a simplified simplified fraction. It's not repeating. So that's why you have to understand the difference between a irrational and rational number, which is on your vocabulary this term, or this semester, or this module. So with that, just understanding what's going on in the discriminant and how we come up with that. Go back here and reference that. Right here. One real root. And here is the discriminant, understanding that, again, A, B, and C. So when we plug those numbers in, we find out that the discriminant came up to 44, which means that we have two real roots. The discriminant is positive and not perfect square, so the roots are irrational. So let's see, and just thinking about the discriminant again, it's inside the radical, and the square root of 44 is going to be irrational. In this answer, we have A, B, C, and I would take a moment to do this on your own, stop the video, and then and then check it out and see how well you did. But this is going to be 8 squared, right? B squared minus 4 times 2 times 8 is going to equal 0. So 64 minus 64 equals 0. 0 equals 0. So I don't need to keep putting that 0 on there. I'm sorry. The discriminant is equal to 0. 0. So there are one root. There is one root available for that because the square root of 0 is 1. Let's see here, and if I need and then discriminant of complex numbers, again, getting to the point, if it's negative, you do need to understand that that is going to be 2 complex roots. We're not going to worry about anything more than that, but you are understanding the premise and understanding of it. So with that, that is using the quadratic formula and understanding the use of the discriminant and finding the types and number of solutions. So get a lot of practice with this. Again, quadratic formula is not the shortest method. It's the longest method, but it is tried and true and will give you an answer.